Just a brief background on me. I'm an EE. I used to design hardware at Tesla and Taser, so automotive stuff, consumer electronics, power electronics mostly, but a lot of iteration, a lot of boards. I used to be the customer, and then I kind of went to the other side to manufacturing, largely because Royal originally is a family business, and my dad started about 20 years ago. So we built it up into a pure U.S. manufacturer. We got 4 factories here, almost 400 employees, one of the largest quick-turn prototype assembly and fab shops in the country today. And I'll kind of go over a brief background of the industry to do this talk. But the main principle for this talk, the idea, is to give everyone a good understanding of the cost structure of our business and why PCBs cost money in general. And why everyone wants their boards for free, but we just can't afford to do so. But what you can do to really, really drop the cost on your end and kind of do a good job, and Oshpark and people like that are great kind of push towards that. So with that, we'll start. So, excuse me. Before I jump into this, how many of you guys have ever ordered a PCB? Okay, so everybody in here has pretty much ordered a board. All right, and for those walking in, just what we were talking about is what the talk's going to be about at a high level, cost structure of printed circuit board fabrication and assembly business, how you guys can kind of drop the cost on your boards, but ultimately why boards cost money to make. And a lot. Thank you very much. So I asked, sampled the room, who's ordered boards. You know, shout out a couple names from fabs or people that you guys have used. Advanced circuits. The advanced circuits is our nemesis. I'm never going to say that one. Sure. So the whole mix. Have any of you guys ever done ordered assembly for like prototype assembly for like 5 or 10 boards? Yeah. Okay. Good. So you guys have a rough idea. How many of you guys have actually ever visited a PCB fab? Okay, so you've seen a few of you guys, but it's like a third hands on. So here's a quick walkthrough just because I'd like to prime the talk with this. So this is running through our shop, and this is one of our fabs in Hollister. That's the 2 buildings. These are big buildings that we're going through. First is just the front office, you know, kind of conference room, the number of salespeople, order entry, etc., quoting, software team. This is part of the CAM team that does all the pre-process, pre-production engineering. And then we walk all the way across a lot to the main fab, which has since been kind of face of stock material, testing, shipping. Now you go into the wet process area. And most of these machines you see are over $500,000. The newest laser we bought was $1.2 million a piece. Just to give some costs, some of the drills, lamination, layout, routing, more routing. And pretty much every single step that you saw, even a 2-layer board has to go through to get built. And all those people you saw, even a 2-layer board, that guy's touching it, and all those people have to get paid. It's somehow right. Just to kind of show what this business is actually built on, the capital intensiveness of the business and how many machines we have that have to be kept running, and then what it really takes to kind of run this business to tailor to super quick turns. Like we do 2-layer boards in 8 to 12 hours. And we do overnight turns for people, same day, 6 a.m. files, 6 p.m. I'm driving them to San Francisco to be delivered to like some of the big tech companies and things like that. It needs things just faster to develop kind of the rate of software. And to do that, you have to put a lot of money into equipment, people, overtime, shifts, etc. So at a high level, most people in your design goals, your goals are to make it manufacturable, cost effective. You want it fast, so you can keep iterating. You want to make time is worth something, contrary to some people's popular belief, and then it should be ideally somewhat scalable. So that mostly has to do with the assembly side, your picking your components and things like that. So at the basic level, routine practices, this is a fab note. And then you guys ever sent in a fab note when you sent your boards to be manufactured? A few. But this is something that, depending on the complexity of the board, but generally it's like a PDF note. This is like a standard fab note. When I was at Tesla, this was what the fab note looked like. Funny quick story, when I first started working there, I hadn't never used a fab node before, so I had a quick LED board, simple 2-layer board. I just had to send it to be fab, so I sent it to our fab to be built. And they were like, oh, you know, if you send it out, you have to use our fab node, just some corporate kind of bureaucracy. So I sent it out with this fab node, I just copy-pasted. I get the board back. It's a rigid board, but it's like totally bendable. Like, this is 7 mil thick. How am I going to run LEDs on this thing? What the hell? And then I looked through the fab node, and they were like, yeah, but your fab node said 7 mil thick. I was like, why would I ever do that? But it's just because I copy-pasted. I didn't read the fab node, but the fab house will read everything. So it's a blessing and a curse. If you don't specify things, sometimes, usually it'll go on hold, we can't assume, but oftentimes if you send something and they're not ready, things are not backfire. So, this is, if you just take a screenshot of the slide or whatever is available after, fab assembly and layout, at the bare minimum, this is what you need. And most of these things are pretty clear from the manufacturers that you've used. But having the native CAD or the Gerbers or something like that for fab, along with a set of fab nodes that'll mostly be relevant for boards like over 2 layers with special materials, rather than sending an email like, oh yeah, by the way, make it Rogers hybrid, you know, passing and add $1,000 to your board. That might be a good thing to do up front. Via fill, if you have like barrier applying vias via and pad, they pretty much require epoxy via fill. Not everybody realizes that, and it has 3 days time. So be really, really cognizant if you're going to add those things. So on the fab side, with DFM, some basic stuff as you guys are designing your boards. One thing that isn't always inherently clear is this copper trace width and spacing and that relationship between the two. So copper trace width spacing and how that relates to the weight of your copper is a big thing. So if you have 2-ounce copper on your board, you can't really get a 3 mil trace. And the reason for that is when you etch a board, it's not etched perfectly vertical, it etches like a trapezoid, kind of like this. And so what happens if you have 2 traces right next to each other, it's going like this. And then at the bottom of that layer, they'll show up together. So you need to have enough clearance for it to go all the way down, and you have the clearance in between. And the thicker your copper, the more distance it has to go, the wider that angle when it etches. And so you need to have some sort of clearance, which is why as the copper weight increases, so does the minimum clearance required for your traces space, as an example. Running DFM checks in the CAD tool, many fab shops have this, and you guys should really take advantage of it in Altium or EAGLE or Cadence or KaiCAD or whatever. Downloading the spec, or at least just going on the site and manually entering them and running a DFM check in your tool will at the very least get you within the manufacturer's allowable tolerances. In and out of clearances for the board edge clearance, whether you have some sort of different plating requirement, fab print, and then stack up. This is something that we do. Other fabs do it, but we do it free of charge at the quote stage. Anything regarding the stack up. So if you need help with your stack up or getting to a particular impedance, every shop uses a different, somewhat of a different process for their etching and their plating, and all those numbers aren't known and calculated internally. So if you're running a particular design and you need a 50 ohm trace, for example, it's generally your best interest to send us your requirements, and we would come up with a very specific stack up that would work for you and arguably be cheaper than maybe what you can do or know on your own, because we know which materials to pick, you know, how to give you the right stack up, and then tell you the different trace widths that you should be using to achieve that particular impedance. So this is just the chart that we use for minimum trace space and copper weight. So you see on like a 2-ounce board, the real minimum is pretty much a 5 mil that you would want to do. So not like a 3 mil trace. And a 1/4 ounce you can get down to 3 mil, and then we can get down to about 2 mil on that as well, because our etching is pretty strong. Just more stuff on the DFM like we were talking about. Minimum trace space for VGA 3 and 3. Anything tighter than that would require a blind via, meaning you're going to go through the pad. Now, this is something that isn't always inherently clear to people, especially starting out, because you get these really powerful tools like EAGLE and Altium, and you say, wow, I can connect everything any way that I want. And no, I don't even need to go around. I'll just drop it down between layers 2 and 3 and go around and make a really tiny 2 mil hole. And then it gets sent to us, and we have to give you guys somewhat of a reality check that if you want buried and blind vias, for example, at minimum, that's going to be about a 2 to 3 day turn. Even though I say, oh, everything's a 1 day turn, when you add a blind via and a buried via, especially if they're small, that's going to be 3 days, because now you have 2 lamination cycles 2 plating cycles, potentially 2 drill cycles. That's double the amount of people that's at the touch. It's got to go through different cycles. Oh, also, we're swamped, and we're a quick turn shop, and we have like 15,000 customers doing it. Not that you should be penalized for that, but just knowing that certain things will require double the machine time, double the processing time, that isn't always clear. Like, oh, I could just put the VIA in my CAD tool. It took me 1 second. Why can't they build it just as fast? And then that also adds the cost. Same thing, just another example, solder mass dams, minimum 4 mil clearance just between. Same kind of idea, but just the precision of how we're applying the solder mask and things like that. Conductive via fill, not conductive. This is what it actually looks like under a microscope with these vias. What a good kind of finish for that process looks like. Via fill, very important, especially if you have the in pad, so it doesn't kind of keep popping up. So sometimes you get the board back and like, if I press on it, everything seems to work, and I like how it's just popping up. So you want kind of wrap plating and have your things kind of filled in. But then how you do that, the cost changes considerably, and also the time changes. Via fill is a reasonably complex process. Can't really do those on a one-day turn because of the number of cycles and the time to cure and put it all in.
Which is the conductive or not conductive is faster?
They're about the same time. There's just different processes. Somewhat, the cost for conductive is a little more just for material, but not largely. The one thing that we do, there's only 2 shops in the country that really do it. We're one of them, which is copper fill vias. This is a new technology that a lot of, especially automotive customers are taking advantage of. This is, we literally fill the whole thing with copper, essentially through like a plating type process. And you get really, really good thermal dissipation through these vias. There's a limit to it. I don't have the exact aspect ratio. It's not very large. But especially for like via and pad and some kind of heat sinks, it can save a lot of space on your board by getting rid of those components, and you do these copper fill vias in adjacency with each other. So the other company so Royal Circuits is our fab. The other shop that we run is Advanced Assembly. This is one of the largest quick turn assembly shops in the country. We got over 10 lines, and we do as little as 1 board in 1 day. And the reason for kind of giving that sort of disclaimer is to say that the most critical thing is the data that you send when you want things fast, right? Obviously, because if we get garbage data, we have an issue, we're gonna have to hold your job, and your 1-day turn became a 2-day, 3-day, etc. Now, interesting statistic.
Sorry, I was going to ask you, we've got these Gerber standards that have been around forever. Why isn't there a standard for bombs? Like everyone uses a different format. So is there anyone working on that? Is there actually...
So we have our standard.
Yeah.
We have it on our site. We have our own tool that you upload the bomb, it'll automatically parse it and like tell you select, and that's fine. But I agree, it's not that complicated because of this. Now, interesting statistic, this is true, I just pulled it. So we have 15,000 customers. We build up and tear down pick and place lines 6 times per day. A traditional CM contract manufacturer builds a line and tears it down once every like 6 weeks. So totally different economies of scale the way we're operating the business. But the one stat that has remained true is 98% of jobs that come in have some sort of issue with the bill of materials, with a Gerber, with the footprints or something not lining up. Right? And usually it may not even be the engineer's fault. The Gerber has no 402 package, but the bill of material part says it's no 603, but then you wrote in 0805. And like, which one is correct? And we can't assume that the one we ordered, the part, the order link and the fab, maybe one of the smaller part, I don't know. And oftentimes there's not a clear node, and we're running these so fast. If it's not explicitly clear, huge issue. So that's something that even the software would be hard to catch because sometimes it's a design decision. But 98% of jobs that we do have some sort of issue. Now, 90% of them are not critical and they're easy to fix and they're usually simple. But even so, it's something that takes time. And when you're in the quick turn prototype industry, that can kind of kill you. But really, I mean, whether these are people that work at SpaceX or you work at whatever company, you find it. So at a high level, this is the stuff that I would include every single time: part name, quantity, manufacturer, MPN, ref des, just to make sure at least everything is mapping between your board file and the parts that we're going to order or receive from you guys. But then, if you want, you can add these things that are italicized at the bottom: distributor, part number. The data sheet sometimes can help if there's like a full variance in the part, because sometimes we have to look it up if there's no clear, if it's a confusing type design with little silk screen for pin 1 designators, we have to usually reference the data sheets and things like that.
So,
Yeah.
so notice you didn't have any orientation data required in the bill of materials.
Not the bill of materials, so that's a pick and place file that you want to send. That would have your XYRS for that, and then pin 1 markings are generally either on the silk screen or something that you would put in the bill of materials in the another section. So that's right, I didn't specifically have that.
What's the part name? It seems like.
Oh, like literally the name of the part that you like what is this part that kind of matching with the silk screen? Is it like your capacitor, your reductor, kind of what is it just as a high level indicator of what's going on?
So, and you need that, right? The MPN isn't enough, right? The MPN should be the unique identifier with the manufacturer. Plus manufacturer plus MPN is unique.
Yeah, I agree. As you said, that's fair. All right, you got me. Part name is not required, because sometimes it's just good to have for like total clarity. MPN is good, but sometimes if there's a problem with the MPN, it doesn't link up with like the part name. Usually part name is really, I guess the part name would be description. That's the most accurate way to describe it. MPN is fine, and what's the description? It shows up the digit key just so you can make sure it matches up like this is an IC, it's not a diode, or it's not a resistor. Just for a kind of second sanity check. Although I can see how that adds to a second layer of complexity as well. So designing for cost. Basically, the cost structure for boards at the bare level are based on the size of the board physically, basically how much of a panel it covers, how fast do you want it, and the number of layers. Those are the 3 biggest driving factors for any fab shop in the country. Okay, the size is relevant because any board, we do not build boards individually. Like you have a small 3x3 board, it doesn't work that way. We actually have to put that on an entire panel. And if we're going to run an entire panel for you, we charge you for the entire panel. The good thing, I guess the good news about that for the engineer though is if you want 1 or if you want 100, if they all fit on the same panel, the price theoretically should really be the same for fab, because all we're doing different is we're imaging it. But there's no difference in it besides maybe the time it takes to test, which we don't charge for anyways, and then the time it might take to do any sort of rework, like with final QA or an AOI, the optical inspection. But for the most part, we run an entire 18x24 or 21x24 panel through the shop, no matter what. That's the only size we can run through all our machines and plating processes and presses. And so to get the best yield, you want to utilize the majority of the panel. That's what Oshpark does. You send them their files, and they kind of consolidate everybody, so you're just paying for your share on that real estate. And so to make the most of your design, you want to use up most of the panels, so we want to run 18x24. And then beyond that, we have adders. Like I was talking about, blind buried vias, via fill, etc., different types of plating, thicker levels of copper that just require more manual care. Boards are still an incredibly manual process, and they will be for the foreseeable future. It's just kind of a dirty process, but that's still efficient, and the businesses are still profitable, so that's kind of how they built them. But like I said before, via fill, or rather blind and buried vias, are things that require you to separate the board, run it through different drill cycles, run it through different separate lamination cycles to get everything stacked up and drill through the right layers at different times. That significantly adds to the time and the cost, and there's a huge premium on any shop you go to. So avoiding those things is usually good. And generally the easiest one to avoid, if you can, is blind and buried, depending on your design. Usually adding more layers and getting around it that way by still doing full through holes top to bottom is usually cheaper than keeping a 2 or 4 layer board and doing a bunch of burieds and blinds. That's a good example.
So once you get past one whole panel, you're doing an 8-piece panel.
Sure.
What sort of volume discount is there?
So this is another interesting thing that isn't always intuitive. For boards, as you buy more boards, the unit cost is going to go down, right, per board. And usually, because we're a quick turn fab, low volume, usually 1 to 10 panels, your price is going to be pretty good, your unit cost is going to go down. Once you go to 10, that curve starts to change because now we have serious capacity issues at the shop. We have 20 panels of your job, but I have 2 panels of other job that I charge you guys $50,000 for, or whatever. And everybody has to get their boards on time. I can't put anybody else. And so that there's a premium for that end, but generally the price discount the price unit cost will go down as your volume goes up. However, with assembly is the exact opposite. With assembly, as you order more boards, the unit cost will actually go up. And the reason for that is it's done on an individual unit scale, like linear basis. I have to run each of those through the pick and place. Now, pick and place, you put them in arrays, fine, that's not a huge deal. The second you get into through-hole or manual assembly, the price jacks up way fast. And that's any assembly shop. So ideally, limit your through-hole parts. That's probably the biggest driver of cost there. And then the number of unique line items, because that's loading the pick and place and things like that. The good thing about us, we don't use stencils. And we use really, really high-speed precision trace printers. And these things will get the exact amount of solder deposition on every single pad. That'll give you a different amount of solder on a PGA pad versus like a 142 resistor. So you kind of get the right amount going, and it's way faster because it's all software driven. I'll have a difference in solder whether it's a 300-pound guy or a 120-pound guy, applying the paste to your board. So it's just a lot more even accurate and software driven. And I need to charge the tooling costs, especially the second time around, because it's already in the software. So yeah, for fab, it's high-speed layers, and then you have your different adders, special surface finishes, things like that. And then for assembly, it's what we're talking about, through-hole parts, whether you're one or two-side assembly, number of line items, and of course, total number of boards that you'd like to get assembled. And this is really speaking on a prototype level. Do I have like 5 minutes? Yeah, barely.
Yeah.
Sure. So this one is probably the most important because most people have no idea. Some people don't care, and that's fine. But generally knowing who you guys buy your boards from is incredibly important. So if any of you guys ever used a contract manufacturer, a CM. So CMs, a lot of people don't know, mostly they don't have their own board shop. They're assembly shops and they subcontract out work. And it's easy from like a business standpoint if you're the one buying it because it's just like great, look at one guy, it's easy. People don't realize always is CMs generally have like a sub 5% profit margin. They're not really good businesses, and the only profit that they make is certainly not on the assembly. I mean, you really can't make profit on me placing a resistor, because how much could I possibly charge you for that? You can't really grow a business that way. The way you make profit if you're a CM is on the markup on the bare board. So you really want to push people turnkey, and you want to have an outside board guy strangle him, which is what we have to go through every day. And then they add a $500, $1,000 markup, and that's the profit for their business. So generally going direct will save you a lot of money because you're not paying a premium for somebody to blindly kind of operate. And they just kind of get faster service and things like that. But not everyone knows that. But there's obviously benefits to going with the CM, especially when you're with volume production and volume, and then for some supply chain stuff. But generally for prototypes, if you can go direct, it will save you a lot of time. And then who is your fab shop? There's a lot of brokers, people that don't necessarily own shops at all, but they're still selling individual boards at a really, really high price. And you're like, how does this make sense? It's like 8 guys in the sales office. There's like 30 in San Jose alone. And they have customers because people don't ask or they don't care. And you're like, I had no idea. It's just charging premium. So kind of knowing who buys the business. Does this fab or assembly shop have multiple? Because if you're in the quick turn business and your etcher goes down, you're out of business. So are they financially sound, like able to kind of put money towards 2x of everything, your etchers, your line side air, your line machines, your routers, your drills. So that's kind of that, is because this is kind of a rush timeline. The last 3 things, briefly, are 2 things that we're doing a little differently, not like your traditional fab. We're thinking more 5, 10 years down the line. In 2008, there was 2,000 PCB shops in the United States. Today, there's 135. So 95% reduction in the supply, but the demand is at a minimum 2 to 4 times higher. How does that make sense at all from an economic standpoint? Fine, 80% of that decrease was due to China, and people not being able to put money back in their own business here and build more of the high-end stuff that people are not willing to do there, military stuff, and ultra quick turns, same day, next day, 2-day turns. But within that, there's like 10 or 15 shops who are part of that group, and it's still fragmented. None of us own more than 10 to 15% of the market. So it's a super fragmented market. We're all fighting for the same customer. We're trying to get the same engineer to buy from us. But 2 to 4 to 6 layer boards are essentially a commodity. So what we're doing is almost pushing on this whole idea of democratizing hardware and putting software towards that end. So one of the things we've done, we just finished this public API, prioritypcb.com, essentially allowing anyone to become their own PCB broker. And sell, we become more a white label manufacturer, just building good quality boards and focusing on that, and less on trying to just sell people blind. So if you have a website with like a niche customer group, for example, and you'd like to sell boards and collect a piece of the revenue on your site, you can use this API. If you have your own website, or you want to build your own platform for this, you can order boards directly through this. They go directly to our factory floor, ties directly to CAN, you save all the sales, this, that, and the pricing a little better on you, but you'd have to kind of build some of the tool around our API to do so. Fab and assembly.
That's the kind of thing that someone should build into TEARDOWN or EAGLE or something.
Well, so that's the next thing. I just got an email from Matt and the other guys at EAGLE yesterday. This is going in the next release.
Right.
Same with our layout service. So that's the idea. So you can build a board, hit next, and then it just builds it. So I also run a company called PCBlayout.com. This is a larger design firm. We do layout, library management, parts, schematic symbols, footprints for really, really cheap, like $5 to $10 in 12 to 24 hours. And we do layout at like roughly 50% of the number of total pins. So it's a really, really good price. And the whole idea that we do boards for everyone from like big corporations to hobbyists and hackers, but that's kind of leading into manufacturing, and the big benefit is we own the manufacturing company as well. That was kind of the reason behind this. We're like, we get all these files that are kind of garbage, we don't know their design decisions. What if we made a design firm that helped people with their designs, but we give something to you that's guaranteed to be manufacturable at the fastest rate at the lowest cost? And then the last one, I kind of gave you this growth circuits, 4 factories, Bay Area, LA, Denver, another one in the Bay Area, all US based, prototype. You can look it up, lots of the sales thing. This is one I really want to show you guys. This is a startup I just invested in San Francisco called Debugger, using augmented reality to debug PCBs. You basically upload your files and it'll parse right now EAGLE and Altium. And it'll allow you to see things kind of through one lens instead of having to open up your whole Altium file. So in real time you can parse and then know, like, let's say your LED was not blinking. So the first thing you're going to do is start to probe, but to know where to probe, especially on a dense board, is very difficult. So this way, you see the value of every single component, you see how everything's connected via the nets, you know exactly where to probe, and then going down the line, you can have all your different screens, like your oscilloscope, your DMM, all on one lens. So you don't need to be looking at 7 different things, kind of fragmented. You have everything at once. So that's the idea behind this product at this first level. So something that I'm loosely involved in. Just to kind of give you a sense, but more showing that when you work with us, you're not just with your traditional fab shop, 30 employees. We're like thinking world domination, next level. So we're always open to new ideas, and we love working with people. If you guys have a small project or a startup, we'll hook you guys up. Just trying to be a part of the community for sure. So